Okay, so 2.2, this is what you'll be learning. Identifying common features of a graph of a logarithmic function. So like when we say common features of a graph, think about all these functions as families. We've got our quadratic family, over here we had our exponential family, and now I'm introducing you to our log family. And all the logs have some features in common, just like you. I don't know if you look at me and my family, like some people say that me and my daughter look very similar. Some people say that my son and my husband look very, very similar, especially when, certain things that he does. So there's certain features that are naming you out as like, hey, I kind of look like I'm part of this family, right? So same thing goes for logs. Like when you see a function that reminds you, hey, you look like a log, most likely it's a log function, right? How we're going to transform. Now, remember, transform, we used, I don't have it anymore. I think I closed it out. I did. Remember, we used the tangrams to rotate it, to translate it. And then reflecting it, remember, we're thinking like in the mirror. So what are the features of graphs of log functions? How can you use the features of the parent function to transform log functions? And lastly, how does transforming the graph of log functions compare to transforming graph of the quadratic functions? Okay, so you guys have had really good language on the two that we just did, saying to the x, to the y in the parentheses. Those things will apply here as well, and you'll see and you'll understand why that makes sense. Okay, so just moving on here, again, going to use my log table and my graph as well. It says construct a table of values and a graph for each of the following. So here I'm going to just tell you right now, I'm a huge fan of using a graphing calculator. But make sure that it goes in your head and not just into the calculator, right? So the very first thing that I do is I pick a couple of good values. I go 1, I go 2, I go 100 or whatever, like that, right? I'm going to choose a couple of good values. I'm going to see what my answer is. Oh, my computer. Oh, there it goes. I'm going to see what my answers are, and then I'm going to construct that. So I'm going to actually use this to build my table. So I'm going to hit plus, and I'm going to hit table, and I'm going to go like this. So I'm going to go 1 to 100 just because those are the numbers I used. And then over here, I'm going to change this so it's using my log base 2 of x. My log base 2 of x. Maybe I won't use 100. So I'm going to type in log base 2, that's this guy right here, of x. Now, see this little hazard sign? He's like, hey, I don't know what you're talking about, but I want it to pull from this right here. So I've got to tell him, hey, pull from this column. This column is called x sub 1. So I'm just going to put a little 1 there, and then it's going to know exactly what I'm talking about. When I don't put a 1 there, this program is saying like, what are you talking about? Who do you want me to take the log base 2 of? So here, if I say use log base 2 of x sub 1, then it's going to pull all those values. Okay. So I don't like the number 100. I'm going to use the number 4. I'm going to use the number 5. I'm going to use the number 8. Oh, look at those values there. So I'm going to copy my little table. I'll put this down. Hold on. Numbers. I'm going to use this table. How do I get it? Okay. As my function values. So I'm going to copy those here. I'm going to take a snip of this guy too. This guy right here. You all see my little function. I'm going to graph that. I'm going to copy that and put that right here. Okay, so here goes that. That's my function for that one. I'll put it up a little, right? So when I plug those in, I got 0, I got 1, I got 2. Oh, I got 3 when I plugged in 8, which makes sense, right? Because again, if these are the exponents, these are my powers. So log, right? Vice versa that. So I would graph this, of course, right here. And then I actually want to graph the function itself just to see what it looks like. So log base 2 is right here of x. And so this is the function. This is what it will always look like. So get that curve in your head. Get that curve in your head. Yeah, I just chose random ones at first. If you notice, I chose 1, 2, and then 100. And then I noticed that it was log base 2. So then I used, where's my table? I used 1, 2, 4, 5, and then I remembered, oh, that's what it means, right? I should use powers of 2 here, because then that's going to give me some nice numbers to actually plot. And I'm just going to say this out loud. If you don't plot this really, really, perfectly, I don't need it to be perfect. I just need it to be a sketch. A sketch is like an estimated drawing versus a graph is an exact drawing. Yeah, I skipped 5 here. Oh, shoot, I put 2 here. I skipped 5 here because I didn't want to write 2.32 or whatever, if that makes sense, right? So yeah, I kept it here. What values do you want us to use, Ms. Johnson? Values that make sense. Now, this is going to be where you're going to learn which values to use. And this is actually a really good task for you to do, is figure out which values. Like, what would be another good value for me to use right here in my table? What's another good one? Yeah, I'm going to get to that point right there. Give me 1 second. Very good. Someone asked, hey, Ms. Johnson, what about this interval right here? How come you're not following that? You'll see why in a second. What would be another good power of 2 to use? Yeah, 16. Why would I want to use 16? Well, because it's a power of 2 to the 4th to be exact, right? So log base 2 of 16, Miss Johnson, is 4. Exactly. Okay, so last but not least, this said to use it to the interval between 0 and 1. Now, if you look at my green dots, they're all positive up here, right? See, boop, 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 right? If I was to use numbers that were less than 1, then you'd see them get closer and closer here. So still thinking on good powers of 2, what's another good power of 2 that I could use that's smaller than 1? That's smaller than 1. Yeah, someone said 1/2, Miss Johnson. Someone's like, wait a second, Miss Johnson, 1/2 is a power of 2? Yeah, it's actually 2 to the -1st, right? So I'm using these numbers here, you'll see, to build my smaller than 1. That's why I did this way. Okay, what's another good power of 2 that's smaller than 1? What's another good power of 2 that's smaller than 1? Oh, 1/4. Oh, I see the pattern, Miss Johnson. Now do you see the pattern? Right? Now do you see the pattern? We don't want to put 0 in. Anybody know what happens when I put 0 in? Yeah, it's undefined. Shown by the graph, right? It's getting closer and closer and closer. Shown by the table, it's undefined. Ms. Johnson, why is it undefined? Because if you think about this, now let me write this down. If you think about, and I'll write this at the top. If you think about log base 2 of 0 equals to some number, right? I'm writing it up here. It's up here. Log base 2 of some number equals to 0. And that's in logs. In exponential, you would take the base, which is 2. You would take the answer, which is what I'm looking for. And I would say, what number does that make it true? What number will make that true? 2 to the what gives me 0? And you're like, Ms. Johnson, that doesn't exist. Exactly. That's why it's called undefined, right? So another good number that I should probably use is probably, someone said 1/8. Exactly. Gives me -3. So those are the values that I'm going to trade out right here in a second, just so that I have a more complete answer, because they wanted the number 0 to 1. It's okay if you use numbers that are outside this interval, but I used these numbers to build these numbers. Does that make sense? So I'm going to take out this bottom half and I'm going to go 1/2. Right? And I'm going to go over here and I'm going to put -1. I'm going to put 1/4. And I'm going to put over here -2, right? Because that makes sense. 2 to the -2 means divide it twice. So that would be 4. And then last but not least, I'll put 1/8. And that'll be the answer, -3. right? And then those are my little dots right there. Do you see how it's more of a curve? So whenever you see this curve, you should be familiar with yourself. Oh, that's a log curve, right? So just like before when you were little, right? You were little, writer, and then you saw this letter. You're like, oh, I know that letter. That's the letter A. So every single time you saw something that looked remotely like this, you would be like, oh, that's the letter A. Even if it didn't look exactly like it, then you learned about the lowercase letter A, right? And then you're like, anything that looks remotely like this is going to be the letter A, even if they were written like this. Does that make sense? These both are A's. This guy right here, both A's, right? They just look a little different from each other. So whenever I see this curve like this, whoosh, right, that's going to be my log curve. Okay, let's move on. They tell you to do the same thing with log base 3. I'm not even going to jump into a calculator. The curve is going to look very familiar. It's going to look exactly the same. It's going to have a couple of different points here. So now that we know that, now I'm going to tell you levels of understanding. Here, Miss Johnson, why did you choose 1, 2, 4, 8 at first? Anybody remember? Why did I choose 1, 2, 4, and 8 at first? Why did I choose 1, 2, 4, and 8 for this one? Yeah, because it said log base 2 of x. So we wanted to look for powers of 2. I wanted to look for powers of 2. Oh, okay. So what kind of numbers should I use here, y'all? Give me some x values that I should use. Yeah, I should use powers of 3. Very good. So what are my powers of 3? Very good. Very, very good. Get in there. Get your answers in there, people. Okay. Now, some of you, you're giving me multiples of 3. I don't want multiples of 3. I want powers of 3. So basically, I want to go like this. Look, if you want to think inversely, go like this. 3 to the first is 3. 3 to the second is 9. Right? 3 to the third is not, right? It's 27. Right? Very good. All right, good, good, good. Okay. So I got a couple more people getting it. Okay. Oh, but Miss Johnson, they said from the interval of 0 to 1. Okay, then fix your numbers. What should the rest of my table look like then? What should the rest of my table look like then? Yes, it should be fractions. Very good. Okay, so go ahead and fill that out. I'm going to give you a couple seconds to fill that out. Very good. Very, very good. Go ahead and fill that out. So I'm just going to make these the reciprocals of themselves. So I got 1/3, I've got 1/9, and I've got 1/27. For those of you who put 81, I would put 181 as well. Here, let's do that right here. Oops, not 85, 81. And then over here, so 3 to the what gives me 1/3. 3 to the what gives me 1/3. Yeah, it's -1. Now, for those of you who are still like, that makes me yucky, I want you to think about this, right? I need you to think about this. How many factors am I dividing by 3? Well, 1. Oh, okay. So dividing means negative by 1 set of 3. Exactly. Does that make sense? Very good. So for those of you who are like, I don't want to participate. Please just participate. Get your wrong answers out now. Look, if you don't get a wrong answer, I don't know. I think about doing wrong answers, like that's when I really learn. You don't really learn when you get a right answer in. I'll just say that right now. Like, does everybody remember touching the stove for the very first time when it was hot? And your mom just had to go like, hey, that's why we don't touch it. Like, exactly, right? So when you get a wrong answer in class, you're not going to get that same, I mean, if, as long as you reflect on, okay, well, why was that wrong? Oh, that makes sense, right? Okay. And for those of you like concerned, oh no, everybody's going to remember my wrong answer. No, you don't. No one even remembers who gave the wrong answer in here earlier, right? Unless you do. Then if you do, then keep track of your own wrong answers. So that way you can improve your own quiz. All right. So how many factors of 9? Wait, no, the other way. In 1/9, how many times did I divide by 3? How many times did I divide by 3? 2 times. So negative means I'm dividing 2 times, exactly. And then we got -3, and then we got -4. So if I graphed all these, it should be the same thing, right? So go ahead and graph those really quick. Go ahead and graph those really quick while I grab some participation stuff. Very good. All right, so I'm just going to graph really quick. 3, 1 looks like that. 9, 2 looks like that. You can kind of see that curve right there, right? You guys all see that curve. And then going this way, 27 is off the board. 1/3, -1 is really funny. Looks like that. And I can't get any closer, right? So you guys all see this curve happening right here. Does everybody see that curve happening? Yeah, very good. Okay, so that's done. So then they want you to construct a table for log base 10 of x. Remember, I told you that log base 10 of x is equal to log of x. Ms. Johnson, where did the 10 go? Where did the 10 go? It's invisible. Just like your square root symbol doesn't have a little 2 here. It's understood by everybody that there's a 2 right there. It's just understood. So everybody understands that there's a 10 right here. He's invisible. So again, think about what good factors would you use here, right? What good factors would you use here, right? So answers are going to be the same. So I'm just going to go through this really quick. 10 to the first is 10. I'm just going to do 2. 10 to the second is 100, right? And then I'm going to flip these guys. I'm going to go 1/10. And this would be -1. This would be 1/100. And then this would be -2. So you can kind of see that curve still happening, except for this guy is a little bit like imagine me graphing this right now. 10/1 looks like this, right? Right? He's all the way out here. It's like really flat. He's flat, right? Compared to this guy, he's not as flat. So 10/1 looks like this. Let me use orange. For the next graph, do you see how he's right here? Do you see how he's going to be flatter? He's like closer to the x-axis. Yeah. Okay. So you guys can finish this, no problem. Things that I wanted you to think about. How did you decide which values to use in the table? We talked about that. How did you use the x values to find the y values? Remember, I did this. I said 10 to the first is 10. Eventually, you will get so fluent in logs that you will say log of 100, oh, that's 2, right? Eventually, you'll get there. Right now, you're still getting like used to thinking about it like this. So that's how we did it. We did it using the inverse, right? We went this way, y then x, right? This one says, what similarities do you see in the graph? So you guys tell me, what similarities do you see here and here? And then very clear, oops, he's over here, sorry. I didn't grab him. I didn't catch him, but there as well. What similarities do you see? And then they should all be part of that family of curve, right? And then here's the, I need you to listen to this question because some of you already have this answer. What is the effect of the graph of changing the base on the graph of the log function? So what did we talk about this one with a base of 10 versus this guy with a base of 3 versus this guy with a base of 2? So if you want, we can just graph them all on the same one and then you would see. So anybody have any Ms. Johnson, this is what I see. Log base 2 of x. I'll copy this so I don't have to do that over and over again. So make this one a 3. What effect does this base have? Oops, where'd it go? I'm just gonna erase my base. So I'm gonna make this bigger. Ah, you guys all see that? Sorry. So if you look at the red guy is our original guy, right? And then log base 3 of x come in. Remember we talked about it? It's almost like he's being squashed. He's pushed closer to the x-axis. And then here he's all like, boom. He's even like closer, right? Because if you think about the powers of 10, right? 10 to the first is 10. So that's why you got this guy, this point right here is 10, 1. Versus log base 2 of x. If I plug in 2, then I get out 1. That's the red guy right there. See that point right there, 2, 1. Versus our green point, I can't even point at it. Does that make sense? So that's the deal with that. Hopefully that makes sense. All right, I'm going to stop this.